Acetic acid here. OH here, when we add sodium hydroxide, that's what will generate. And the acetate ions here. Okay. So this is before addition. Before addition. We added addition. And after addition. So we'll have something like this, something like this, something like this, and something like this. Okay, this goes this way, this goes this way, this goes. And in order to do it in number of moles, okay, find how many moles of the acetic acid on 50 milliliters. 50, we have 50.0 milliliter of acetate buffer. The molarity of acetic acid here what is the molarity of acetic acid? 0.036. Okay, so the molarity of acetic acid 0.036. To find the number of moles in 50 milliliter, what you do? You have 50 milliliter here. This is for this guy here, 50.0 milliliter times concentration 0.036 molar divided by 1,000 milliliter per liter, and the number comes here after you do the math, 1.8 times 10 to the minus 3. It is confusing something. You remember, we have only 50 milliliter of that buffer. We're not doing in the whole bottle, in the whole flask. We only took 50 milliliter. You understand? Milliliters times molarity divided by volume in liter give you number of moles. How many moles of the hydroxide ion? We added 1 milliliter of sodium hydroxide. And its molarity 6. So sodium hydroxide would be 1.0 milliliter here times 0.60 divided by 1,000, and this will be 6.0 times 10 to the power minus 4. That's before addition. That's what we have. What will be the acetate ion? Acetate ion. What we took 50 milliliters here, 50.0 milliliter times what was the acetate? I'm putting the numbers maybe. Let me double check my number, guys, here. If that's yeah, I think 0.096. Yeah, 0.09068. That's the correct number. So this here times 0.09068 and divide by 1,000 here, 1,000.0 milliliter per liter, and your number here comes out 4.5 times 10 to the minus 3. 4.5 times 10 to the minus 3 moles. I think we put it the other way. Okay, you with me here? You understand where I came up with those numbers? I took 1 milliliter of sodium hydroxide. How many moles of the hydroxide? 6 times 1 milliliter times 0.6 divided by 1,000 milliliter per liter. So now what happened here? What we added here? So this 6 times 10 to the minus 4 will react with the acid, and here will be addition will be minus 6.0 times 10 to the power minus 4, and this is OH. We already added that much because we have more of the acid than what we got. This will be 0 here. Will be minus 6.0 times 10 to the minus 4, and now the acetate ion will be plus here, plus 6.0 times 10 to the power minus 4. If you get this clear, we are good. That's all you need to know, how these things come out. Now you did the math. So this is actually 6 times 10 minus 4, 1.0 times minus this, add this, after addition will be, this is will be 1.2 times 10 to the power minus 3. This is 0, OH already gone. We have excess of acid there. And this will be 4.5 times 10 minus 3 plus 6 times 10 minus 4, like, plus 0.6. So that would be 5.1 times 10 to the power minus 3. Digest this and let ask me a question if this is not clear, what I did in this table here. Okay? After addition. Now, all I have to go back to my equation, pH equals pKa plus log acetate ion CH3 CO minus over acetic acid. Okay? Clear? pKa is 4.74 plus log acetate ion 5.1 times 10 to the minus 3. This is 1.2 times 10 minus 3. And pH comes 5.4. Sometimes my number, they might not as, but expect yours to be good numbers. So, and pH, and pH 5.4. Okay, think of this table now. Try to do the same thing for yourself and for the second one, for example. The difference now, when I'm adding acid, this is adding sodium hydroxide. 50 milliliter of acetate buffer plus 1.0 milliliter of NaO of 0.60 NaOH or whatever. Okay, water here. Okay? Can you guys do the second one? pH of 50 milliliter acetate buffer from plus 1 milliliter of HCl. Just think of it this way, where is the HCl goes after what? So actually you have to replace this by hydronium ion here. And think of the hydronium ion, where does it go after? Which will go after in that buffer solution, and that solution was supposed to guarding your, trying to control your pH, where it goes. Goes after what? The second part. Okay, let me clean up only this thing here, and only what you say. Okay? Can you do that? The second one? Look at the table here and see what you're going to change here. So when you're adding HCl, it's going to go after the acetate ion. So your acetate ion here will be decreased by -6 times 10 to the -4, right? Your acid will be increased by +3. And you do, everything initially is the same because we're using 50 milliliter. Do this math and see if you have a question. And then I can move to the last one. Anybody has a question with the, you know what to do with this? 50 milliliter acetate buffer. Now we're adding hydrochloric acid instead of adding sodium hydroxide. Then where's the hydrochloric acid go after what? Proton will go after the acetate ion. So this will be increased, and this will be decreased, you know, and this will be increased. I can just go ahead and clean it up here and see if, think of it how you, so I'll put here, H3, hydronium ion plus. Now this will react with acetate, and this will be minus, and this will be plus, and this will be 2.4, and this will be 3.9. And just U will be 3.9 divided by 2.4. Okay. This buffer lab has actually more calculation than anything else you can do. I don't know, but this could be a good question in the final exam because this will be easy to do. They give you the, say, 50 milliliter of acetate buffer plus 1.0 milliliter of 0.6 molar, and they give you the initial molarity of the acetates and initial molarity of the acetic acid, and you want you to do the math and find the number and compare to the what's given to you.